Na 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 physics. Na 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 lesson 9.2. Na 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 electric field. Beaker. All right. So, physics lesson 9.2. First thing I want you to go through is the similarity between gravitational potential energy and electric potential energy. So these are both governed by this distance, right? So just like gravitational potential energy is dependent on the distance from your Earth, so the closer to the Earth that you are, then the closer you are with the force of gravity. So you may remember it as looking at force equals big G, m times m, divided by the distance squared. And electrical potential is very similar, and it depends on your distance. So let's look at some electric fields. So here we have a positive charged ion, and here we have a negative. Notice that the electric fields that they generate are opposite. So positives go out, negatives go in. So when we're drawing them, we need to indicate that show. Alright, so let's say we have two spheres. They're 4 centimeters apart. Sphere A has a positive charge. Sphere B has a negative charge. Draw the electric field that they would make. Alright, so let's go ahead and draw a couple lines here. 4 is probably good. Alright, so here's the electric field that they would have not near each other. But then they come in contact with one another. So the positive wants to go into our negative. And we get our electric field like that looks like this. So if I was just drawing the electric field, it would look something like this. Positive to negative. Positive to negative. Right? Where this is the negative end and this is the positive end. And then anything placed in here would react with this electric field. So let's look at what would happen if they were both negative. Right? Negatives go in. Negatives go in. So how would these interact if they came close to one another? Well, they would repel. You need to have an electric field that looks like this. They're repelling one another. Right? What about if they're both positive? They would repel as well. Right? So, big idea here. Likes repel, opposites attract. I lost my spot. Alright, there I am. Alright, so identifying the charges. So went through this in class. These are different arrows. So we should have what's over here? They're going in, so it should be negative, negative. Over here, this left one over here should be positive. This one over here should be negative. So we have a positive and negative charge. Those are negative, negative. Over here, let's label which one is which. So this one should be positive. No, let's do it like this. It's positive, positive, and this one is negative, this one is negative, this one is positive, this one is negative, This one's positive, and this one is negative. All right, then I want to draw a box around the stronger of the two charges. You can tell it's stronger because there's a larger electric field around it. These are really bad boxes. I'm sorry. It's just one of those days when my box drawing abilities is not up to par. I apologize. I'm sorry. Sad face. Tear. Another tear. Hair on the smiley face. He gets one ear. Kind of looks like the guy from the Goonies. Okay. Anyways, I will see you next time, and we'll move on and talk more about circuits. How fun is that? So excited.